Okay, this is going to be a quick presentation this time of some of the core principles and processes that are used for calculating the Spatial Habitat Suitability Index within the FEAST software. Now, the FEAST software calculates habitat suitability at two different levels fundamentally. First of all, it calculates it at a feature level, so it might be a woodland or a field or a hedgerow, and it uses the attributes of that feature to determine the suitability for different species requirements. And so whatever indicator species you pick, it'll do a calculation for that individual feature. The second level is at a spatial or landscape level. It draws upon those feature level assessments, but then also tries to take account of the connectivity in the landscape and the complementarity in terms of all the habitats that a species needs within a particular range for that species, and are they accessible. So we're just going to explain, not in too much detail, but the basics of how these are calculated spatially. So there are three core elements that we're just going to run through. First of all is the species range and habitat complementarity. The second is habitat suitability between features, so are there stepping stone habitats for example, or are there barriers in the way? And then the actual connections between features, are they directly and indirectly connected? So we're going to take an example landscape here. We can see here an arable field with some blocks of woodland, and we can look at that from an aerial perspective. So that photo is taken from this angle here. So we're looking at a sort of patchwork of woodland and fields in this landscape. Now, thinking about the first of those functions and elements, species range and habitat complementarity. Now, this first element is relatively simple. What we want to know is whether all the habitats that a species needs are within a particular range of that species. So we can take this little block of woodland here that I highlighted green, and then look to see, well, what is within a certain range, here with the yellow dotted line. And so we can see from that then all these other areas shaded green are actually within the range of that particular feature there. So what that tells us is maybe that actually for a particular species that forage habitat might be available here, nesting habitat might be available here, commuting habitat is here. So we can start to work out of any particular species and what its requirements are, whether they are within the range of that particular feature there. And then we can start calculating scores based on distance, habitat suitability scores of other features to see if the complementarity is there in the landscape. So that's the first level that we can calculate within the tool. The second level is habitat suitability between features. So if we come back to our landscape here, we can take each feature and work out what's between it and the other features around it, and whether those features have got a habitat suitability for that species. So in this instance, we can start with our same block of woodland here and then pick this bigger block of woodland over here to the west. Now what the software can do is actually start to go, well, we know we've calculated the habitat suitability index for a range of other features, be it this block of woodland here, these arable fields here, this hedgerow here, and so forth. And we know the scores for that, the various habitat suitability indices for each of those areas. Some are 0, some are higher. What the software can then do spatially is take each feature and draw lines between that and its other features around it. That's what we call transects. So it draws these lines on here, and you can set the number of lines that are drawn, the number that's sampled, be it say 5 lines per feature, or from every point on the feature. The more lines you add, the more time it will take, of course. But the idea is it looks at these transects to see what it crosses between this feature in the east and this feature in the west, on the left and right. What we can then do is we can start to see that actually for this section, this transect here, habitat suitability index is 0, but across this bit here it's 0.9, and then across point here it's 0.5. Similarly, for this transect here, we've got a smaller area that's 0, then we've got a 0.65, and then we've got a 0.1. And so we can use those numbers to calculate these transects, the value of them in terms of habitat suitability between the habitat on the left and the habitat on the right. and you can start to pick up then whether there are significant amounts of what might be regarded as stepping stone habitats, or simply whether there's actually scope for the species to move through the landscape with various bits of habitat available that's suitable for it. We can also use the same approach for looking at barriers in the landscape. So we'll pick another block of woodland here. In this case, we're going to draw some transects across to the block of woodland that's in the north. And we know the habitat suitability indices these different features between the two. But what we also might discover that actually there's a road here. Now, for some species, that road may present a barrier. And so we can give these different features, these barrier features in the landscape, a barrier coefficient from 0 to -1, where -1 is an absolute barrier, and anything lower than that, it's going to be a slight deterrent, but they can cross it if there's a habitat on the other side that they really want to get to, or they really want to utilize. So using this approach, by drawing these transects, we can pick up the different features, be it barriers or stepping stone habitats that are between the features and those around it. Now, obviously drawing lines on a map and doing these calculations can use up computation time, and so it can increase the processing time that's required to run all these calculations. You can switch this off to speed up the calculation, of course, but you'll lose some of this functionality in picking it up. But it depends what you're using the software for. Similarly, the third function, the connections between habitats. Again, this is something you can switch on and off, and this is something that can make a big difference to the processing speed, and I'll explain why in a moment. So in this instance, we want to work out what habitats are connected, either directly connected or indirectly. So what the software can do, it can say, well, okay, we'll start again with this block of woodland here, and we can start to say, well, what's it connected to? And we can run a recursive algorithm to slowly pick up all the connections. So we can see it's connected to a hedgerow here, it's connected to that woodland here, which is connected to that one there, which is connected to this hedgerow here, to that woodland, and to that hedgerow, to that woodland. So we can see all those areas shaded green are all connected either directly or indirectly. And what we can see down here is that block of woodland, though, down here is isolated. It's not part of this directly connected landscape. So what that allows us to do in the software is actually say, okay, well, this block of woodland here, be it woodland block 1, is actually connected to this woodland block over here. So for those species, particularly those that like to travel through the landscape following hedgerows or woodland, certain bat species for example, we can see where the connections are for it to be able to move through the landscape more easily. It's not to say it couldn't go across using the stepping stone habitats, and that's what the transect process in the previous example does, but it also gives us this ability to pick up when something is connected, but more importantly when it isn't connected, and so we can lower the score for a feature when it is isolated. Now, because of this recursive nature, this recursive algorithm, when you've got particularly complex landscapes, so you've got 50 or more features that are all connected, that can really slow down the calculation. It can take a few minutes to run in some instances, and it'll tell you that if that's the case. But if you don't want to have this functionality, you just want to do a quick see, well, is everything in the area that's needed, then you can switch this off, but you'll lose this functionality to determine whether something is directly or indirectly connected or not. Now we can see down here this isolated block here. If we did want to switch it off, we would find that actually, going back to our very first function, this block of woodland is actually within the range of any species from this particular block in the middle here, but we know that actually it's not directly connected or indirectly connected at all. Now if you're only doing a calculation based on whether it's within the range, clearly this block of woodland will probably get the same score as this one down here or this one here in the middle. Whereas if we know it's actually indirectly connected going back here, then it would get a lower score compared to this one here, because this one is connected to this feature over here. So that just shows you the difference it makes by switching these functions on and off. Those are the three core sort of functions that are part of the Habitat Suitability Index calculation. And we can see by having them all switched on, we can see whether all the habitats that the species needs are within the range of that species, whether those habitats are blocked or impeded by barriers, whether there are stepping stone habitats or other sort of processes that allow them to have greater access to those habitats, whether they are directly or indirectly connected, so can they move through the landscape. So in combination we really start to get a good feel for the whole landscape, of how well connected it is and whether it's providing all the habitats that a species needs within the range that it operates. The index and score that is calculated reflects all of those above. However, as I said, if you switch certain functions off to maybe speed up the calculation time, you will lose some of those functionalities, and of course then you're talking about how reliable is that suitability index. But it comes down to your own particular use of the tool. What are you actually doing? If you just want to do a very quick assessment to see whether everything is within range, then you can switch off some of the more complex functions that we've just seen and do that quick and simple assessment. But if you want something that's a fuller assessment, where we're looking at barriers and we're looking at stepping stone habitats, then you'll need it switched on, and you'll just have to see how long it calculates. In most instances it can be very quick, but as I said, in more complex landscapes it can be quite slow, can take a few minutes to run. That brings me to the end. Hopefully that's given you a sort of very quick overview of how some of these functions work within the mapping environment of the tool. And by all means look at some of the other demonstrations which actually show that in operation in conjunction with this presentation to see how it all works. I'll leave it there at that point. Thank you for your time.